two intersecting straight lines cannot be parallel to the same straight line. In this rough diagram, the lines L1 and L2 are two intersecting straight lines. The line L1 is parallel to the line AB. Therefore, the line L2 cannot be parallel to the line AB. This is called the parallel postulate. It carries a description postulate, but people have tried to prove this from the other postulates of Euclidean geometry, or right from the advent of the subject. When I was in school, we were taught that due to the development of non-Euclidean geometries, in which two intersecting geodesics can be parallel to the same geodesic, it is a fact that the parallel postulate cannot be proved. But non-Euclidean geometries are about planar figures made on surfaces that can't be developed from a plane. There are several versions of the parallel postulate. In this video, we will find the sum of the angles of any given triangle without using parallel lines. Let ABC be any given triangle. We take D, the midpoint of AC, excuse me, which means AD is equal to DC. We join BD and extend it till point E, so that BD equals DE. Of course, this is a rough diagram, but that is not a damper. What we do is we join EC right. I am going to extend the base BC to an arbitrary point L. Now, it's not difficult to prove that this angle here equals angle A. Angle A. And that this angle here, angle 1, equals this angle. Let me call this angle 1 dash. Now, till here, of course, this is one of the well-known first theorems of Euclid. This is 1 dash and it equals 1. One of the first theorems of Euclidean geometry. But what we are going to do is we are going to repeat this thing, what we did, the steps we did with triangle ABC, on the triangle EBC. And we are going to assume that the steps can be repeated ad infinitum. So I have to take the midpoint of, roughly speaking, this is the midpoint of EC. And I'm going to call this point D double dash. Excuse me. I am going to join B and D double dash, and I'm going to extend it so that I can't extend it that much here. This length B double dash equals the length D double dash E double dash. It will be somewhere there. Of course, this equals this, because D double dash is the midpoint of EC. Now if I were to join it with what would be point E double dash, except I can't make the diagram fully here. I would have this angle here, angle 2, equal to the angle there. That is somewhere here, would be the angle 2 dash. And this angle here, angle 1, would be equal to this angle. Angle 1 dash would be equal to angle 1 dash here then. Because triangle E D E D dash double dash is congruent to triangle D double dash C E double dash, wherever E double dash would be. I can't make the full diagram here. So this angle equals this angle, and this angle equals where the angle here is. Now 1 double dash is in turn equal to angle 1 dash equals angle 1 here. Therefore this angle 1 dash here equals angle 1 here. Now if we repeat the step here, that is we take the midpoint D dash 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 of this line, of the line CE double dash, and join it with B and extend it further. That is, if we repeat this procedure, if we repeat these steps for the new triangle as well, and I said we allow it till ad infinitum, what we have is this. Angle C equals angle A, my apologies, this is angle ACL, the exterior angle of the triangle ABC, equals angle A plus angle 1 plus angle 1 dash plus angle 2 dash plus angle 3 dash plus ad infinitum. Like in calculus. However, as I pointed out, these angles 1 1 dash are equal. The new angle that would appear here, once the procedure is repeated, 2 double dash would be equal to angle 2, and so on, so on till infinity. So I can write angle ACL equals angle A plus angle A1 plus angle A2 plus angle A3, this 3 dash which would be here, plus ad infinitum. Mind you, the angles 2 dash, 3 dash, 3, 4 so far have not been drawn here, but it's not difficult to see once one tries it oneself how these two visually perceived convergent series are in this diagram. This is angle A plus angle 1 plus angle 2 plus angle 3 is in fact divisions of this angle B into a convergent series of angles. The sum of this convergent series of angles is certainly angle B. So the exterior angle C equals the interior angles, the sum of the two opposite angles, angle 1 plus angle B. From which it follows, after a bit of deduction, the sum of these two angles is 180 degrees, that the sum of the angles of this triangle is 180 degrees, or two right angles. Do go into the material in this video. Bye for now.